Now let's see more practice problems. Integral tangent x to the 5 dx. We will write tangent x to the 5 to tangent squared x and tangent cubed x dx. Recall our identity of the trig functions. We can write tangent x squared into secant squared x minus 1. And then we will have our integral be secant x squared minus 1 times tangent x cubed dx. And then we separate the integral into two parts. Integral secant x tangent cubed x dx minus integral tangent cubed x dx. And they will write secant x squared into secant x times tangent squared x times secant x tangent x dx. And again, for the integral tangent cubed x, we'll write tangent squared x times tangent x dx. And the same, we will write secant x minus 1, substitute for the tangent squared x. So now we will have the second integral right into integral secant x times tangent x plus integral tangent x dx. We'll find both integral in the first one and the second one have secant x tangent x dx. So we will let u equal secant x, du equals secant x tangent x dx. So substitute secant x with u. So we'll get integral u times u squared minus 1 du for the first integral. And then minus integral u du for the second integral. And plus the third one, integral tangent x dx. Then we will have integral u to the third minus u du minus integral u du plus integral tangent x dx. Calculate the integrals. We'll have u to the 4 over 4 minus u to the 2 over 2 minus u squared over 2 plus natural log secant x plus c. We'll see this integral tangent x dx. We can just remember it as natural log absolute secant x. Then we should remember to put back off our secant x and substitute u. So finally, we have our answer is 1 over 4 secant x to the 4th minus secant x squared plus natural log absolute secant x plus c. For this integral of cotangent x squared, let's recall 1 plus cotangent x squared equal cosecant x squared. So here, we first transfer the cotangent x squared into cosecant x squared minus 1 dx. And then we will have two integral cosecant x squared dx minus integral 1 dx. And for the first integral, we'll have negative cotangent x. And for the second part, it's just minus x. So we plug pi over 2 and pi over 6 in. We will have our answer equal negative 1 over 2 pi plus square root 3 plus 1 over 6 pi, which is equal negative pi over 3 plus square root 3. Integral sin x cubed dx. We'll see the sin x has the power of 3. It's an odd number. So it's better to split one sin x off the sin cubed x and put with the dx. Let u equal cosine x, du equal negative sin x dx. Here we will have the integral rewrite into negative sin x squared minus sin x dx. And then we'll transfer the negative sin x squared into cosine x squared minus 1 times negative sin x dx. And then substitute cosine x with u and negative sin x dx with du. We'll have integral u squared minus 1 du. Calculate the integral. We have u cubed over 3 minus u plus c. And substitute cosine x back. We'll have cosine x cubed over 3 minus cosine x plus c. Integral cosine x squared dx. Here cosine x squared has the power of 2. It's an even number. So recall our tips. We'll need to reduce the power of the cosine x and use our trig identity. Cosine squared x equal 1 over 2, 1 plus cosine 2x. So here, we just put in the cosine squared x with 1 over 2 times 1 plus cosine 2x. And then we will get two separate integrals. 1/2 integral 1 dx plus 1/2 integral cosine 2x dx. Calculate the integrals. 1/2 x plus 1/2 sine 2x over 2 plus c. And we have our final answer, 1/2 x plus sine 2x over 4 plus c. Integral sine 3x squared times cosine 3x to the power of 5 dx. We'll see sine 3x has the power of 2, it's an even number. Cosine 3x has the power of 5, it's an odd number. So we have only one odd number here. Use our tip, the odd one will need to split a factor off and be put with dx. So we'll rewrite our integral as sine 3x squared times cosine 3x the 4 and times cosine 3x dx. Let u equal sine 3x, du equals 3 cosine 3x dx. Substitute sine 3x with u. We'll get integral u squared times 1 minus u squared and times 1/3 du. Some student may ask where the 1 minus u squared come from. So here we'll see u equals sine 3x. So cosine 3x will equal 1 minus u squared. And here we have cosine 3x to the 4th. So we just square it again. Then we will get cosine 3x to the 4. And here du equals 3 cosine 3x dx. So here we only have cosine 3x dx. So we will divide it by 3 and to let the equal to cosine 3x dx. And then we move this 1/3 out of the integral, and we'll have 1/3 integral u squared times 1 plus u to the 4 minus 2u squared du. And then we will have 1/3 integral u squared plus u to the 6 minus 2u to the 4 du. Calculate the integral. We'll have 1/3 times u cubed over 3 plus u to the 7 over 7 minus 2 over 5 u to the 5 plus c. We'll get our final solution. 1/9 u to the 3 plus 1 over 21 u to the 7 minus 2 over 15 u to the 5 plus c. Finally, we will substitute u with our sin 3x, and we will get our final solution.